Millions of products are reliant on computer chips, composed of semiconductors, for their complete functionality. Everything from digital products and white goods to smartphones and video games needs processing power. In the case of cars, advanced electronics are incorporated into state-of-the-art parking cameras and engine management systems. Currently, there exists a massive chip shortage. The dozens of microprocessors needed for each new car are leaving manufacturers with a sourcing problem as they vie with the consumer electronics markets to secure the supplies available, driving high industry demand in the process. It is anticipated that the present situation, which has been escalating for a number of years, will continue deep into the new calendar year, as chip production resuming at total capacity will inevitably take time. A number of factors have contributed to the current semiconductor shortage. The impact of the pandemic cannot be fully appreciated or quantified. A sharp rise in device sales had been observed as people became confined, while a lack in the need for cars has forced car manufacturers to reduce orders. This in turn forced chip makers to reorganize production. Even before coronavirus, geopolitical implications encumber the chip industry. For example, the uncertainty created by the mounting tension between the US and China in their trade relations. With their domination of chip manufacturing, Taiwan and South Korea are somewhat monopoly producers, accounting globally for 83% of processor chip production. Serving the biggest players, namely Apple and Samsung, as priority customers. Also adding to demand is the rollout of 5G infrastructure. All in all, backlogs within the semiconductor industry may mean it will take 2 years to address the current situation. It emerged that this industry was suffering prior to Christmas 2020. With the current shortage, vehicle production has consequently either slowed or been suspended by a growing list of manufacturers, including Daimler, Toyota, Ford, and Volvo among others. Jaguar Land Rover has shut factories temporarily as a result of the shortage. As perhaps the world's biggest computer chip manufacturer, Samsung cannot satisfy its customer orders. While similar challenges are being felt by Qualcomm, the company responsible for the modems and processors integral to powering so many of the leading consumer gadgets on the market. Many organizations believe implementing effective initiatives in a semiconductor circular economy is imperative to address the serious imbalance being experienced at present and to mitigate future global shortages. However, there is a question as to whether this can be realized. Shifting from disposal to recycling resources is key. Remanufacturing used system parts, qualified to the same standard as new parts, is a core initiative in the circular economy. In terms of materials, it has been estimated that 1 million smartphones contain the equivalent of 15 kilograms palladium, 34 kilograms gold, 350 kilograms silver, and 16,000 kilograms copper, while under normal circumstances ca. 3% to 4% of the daily 250,000. In terms of product recycling, companies such as ASML and Nikon are generating best practices at embedding circular economy approaches with reach and depth that will foster future success and competitiveness of the semiconductor industry. For example, ASML's Return for Reuse program seeks to reuse old equipment by producing less sophisticated chips, while ensuring progressively sustainable use of materials across processes and the value chain via refurbished products. Nikon, which also manufactures critical semiconductor lithography systems, engages proactively in the 3 rupees of reducing, recycling, and reusing. Fundamental to its approach to realize a model for a resource circulating society. This is an effective means of reducing waste. Energy-saving initiatives such as on-site projection lens replacement, for example, have also been adopted while updating the software. To open up the possibility of a sustainable future, the potential of material shortages needs greater exploration, while success will likely be driven by a circular economy agenda within the semiconductor materials industry. Improved algorithms, powerful computers, and an increase in digitized data have fueled a revolution in machine learning, with new techniques in the 2010s resulting in rapid improvements in tasks including manipulating language. Software models are trained to learn by using thousands or millions of examples in a structured, loosely based on the neural architecture of the brain. One architecture used in natural language processing is a neural network based on a deep learning model that was first introduced in 2017, the transformer. GPTN models are based on this transformer-based deep learning neural network architecture. On June 11, 2018, OpenAI researchers and engineers posted their original paper on generative models. Language models. Artificial intelligence systems that could be pre-trained with an enormous and diverse corpus of text via datasets. The authors describe how language understanding performances in natural language processing, NLP, were improved in GPTN through a process of generative pre-training of a language model on a diverse corpus of unlabeled text. In February 2020, Microsoft introduced its Turing Natural Language Generation, which was claimed to be the largest language model ever published at 17 billion parameters. It performed better than any other language model. On May 28, 2020, an R14 preprint by a group of 31 engineers and researchers at OpenAI described the development of GPT-3, a third-generation state-of-the-art language model. The team increased the capacity of GPT-3 by over 2 orders. 60% of the weighted pre-training dataset for GPT-3 comes from a filtered version of Common Crawl, consisting of 410 billion byte pair encoded tokens. 9 other sources are 19 billion tokens from WebText2, representing 22%. 55 billion tokens from Books2 representing 8%, and 3 billion tokens from Wikipedia representing 3%. GPT-3 was trained on hundreds of billions of words and is capable of coding in CSS, JSX, Python, among others. GPT-4 will not be any bigger than GPT-3 but will use more compute resources. This is an interesting announcement considering the vocal voice is against the perils of having large language models and how they affect both the environment. Some expectations are for GPT-4 to also grow and contain up to 1 trillion parameters. However, OpenAI CEO Sam Altman has said that it will not be larger than GPT-3 but will be far more efficient through enhanced data algorithms and fine-tuning. Also alluded to a future GPT-5. The point being that neural networks have a long way to run in size and sophistication. We are indeed in the midst of an age of AI acceleration. The AI-driven transition to a largely automated world will take time, perhaps a few decades. This will bring many changes, with some being highly disruptive. Adjustments will not be easy. This is GPT-4, the device which will change our understanding of what modern technology can do. It will have 100 trillion parameters, which is 500x the size of GPT-3. The company OpenAI was born to tackle the challenge of achieving artificial general intelligence, an AI capable of doing anything a human can do. Such technology would change the world as we know it. It could benefit us all drastically if used adequately, but could become the most devastating weapon in the wrong hands. That's why OpenAI took over this quest. To ensure it'd benefit everyone evenly, the company's goal is to advance digital intelligence in the way that is most likely to benefit humanity as a whole. However, the magnitude of this dilemma makes it arguably the single biggest scientific enterprise humanity has put its hands upon. Although all the advances in computer science and artificial intelligence, no one knows how to solve it or when it'll happen. Some argue deep learning isn't enough to achieve AGI. Stuart Russell, a computer science professor at Berkeley and AI pioneer, argues that focusing on raw computing power misses the point entirely. We don't know how to make a machine really intelligent, even if it were the size of the universe. OpenAI, in contrast, is confident that large neural networks fed on large datasets and trained on huge computers are the best way towards AGI. Greg Brockman, OpenAI's CTO, said, "We think the most benefits will go to whoever has the biggest computer." And that's what they did. They started training larger and larger models to awaken the hidden power within deep learning. The first non-subtle steps in this direction were the release of GPT and GPT-2. These large language models would set the groundwork for the star of the show, GPT-3. A language model 100 times larger than GPT-2, at 175 billion parameters. GPT-3 was the largest neural network ever created at the time, and remains the largest dense neural net. Its language expertise and its innumerable capabilities were a surprise for most. And although some experts remain skeptical, large language models already felt strangely human. It was a huge leap forward for OpenAI researchers to reinforce their beliefs and convince us that AGI is a problem for deep learning. OpenAI believes in the scaling hypothesis. Given a scalable algorithm, the transformer in this case, the basic architecture behind the GPT family, there could be a straightforward path to AGI that consists of training increasingly larger models based on this algorithm. But large models are just one piece of the AGI puzzle. Data stopped being a bottleneck when the machine learning community started to unveil the potential of unsupervised learning. That, together with generative language models and a few-shot task transfer, solved the large datasets problem for OpenAI. They only needed huge computational resources to train and deploy their models, and they'd be good to go. That's why they partnered with Microsoft in 2019. They licensed the big tech company so they could use some of OpenAI's models commercially in exchange for access to its cloud computing infrastructure and the powerful GPUs they needed. But GPUs aren't built specifically to train neural nets. The gaming industry developed these chips for graphic processing, and the AI industry simply took advantage of its suitability for parallel computation. OpenAI wanted the best models and the best datasets, and they also wanted the best computers chips. GPUs weren't enough. Many companies realized it too, and started to build in-house specialized chips designed to train neural nets. However, a pure software company, like OpenAI, can hardly integrate hardware design and fabrication. That's why they took another route, using third-party AI-specific chips. Here's where Cerebrus Systems enter the scene. This chip company already built the largest chip ever to train large neural networks in 2019. First, Cerebrus has built again the largest chip in the market, the Wafer Scale Engine 2, WSE2. It is 22 centimeters on each side and has 2.6 trillion transistors. In comparison, Tesla's brand new training tiles have 1.25 trillion transistors. Cerebrus found a way to condense computational power efficiently, and so WSE2 has 850,000 cores, the computational unit. They also solved the heating problem with a novel cooling system, and also managed to create an efficient I/O flow of data. There aren't many uses for ultra-specialized super expensive mega-powerful chips like WSE2. Training large neural networks is one of them. And so Cerebrus talked to OpenAI. From talking to OpenAI, GPT-4 will be about 100 trillion parameters. That won't be ready for several years. Since GPT-3, there's been a lot of expectation around OpenAI and its next release. Now we know it'll come out in a few years and it'll be extremely big. It'll be more than 500 times the size of GPT-3. You heard that right, 500 times. So, what can we expect from GPT-4? 100 trillion parameters is a lot. To understand just how big that number is, let's compare it with our brain. The brain has around 80 to 100 billion neurons, GPT-3's order of magnitude, and around 100 trillion synapses. GPT-4 will have as many parameters as the brain has synapses. The sheer size of such a neural network could entail qualitative leaps from GPT-3 we can only imagine. We may not be able to even test the full potential of the system with current prompting methods. However, comparing an artificial neural network with the brain is a tricky business. The comparison seems fair, but that's only because we assume artificial neurons are at least loosely based on biological neurons. A recent study published in Neuron suggests otherwise. They found that at least a 5-layer neural network is needed to simulate the behavior of a single biological neuron. That's around 1,000 artificial neurons for each biological neuron. But even if GPT-4 isn't as powerful as our brain, it sure will leave a few surprises. Unlike GPT-3, it probably won't be just a language model. So I hope this gave you an insight into how the GPT-4 device will change AGI forever. Thanks for watching guys, and feel free to leave some feedback, drop a like and hit subscribe if you haven't already. Agility Robotics showcases an increasing familiar sight: advanced, autonomous robots performing boring warehouse tasks. It's not the sort of video that tends to be hugely viral for a company. Rather, it's the sort of meat and potatoes proof of concept that companies like Boston Dynamics wedge between flashy videos of parkour and highly choreographed dance sessions. This is precisely the sort of tasks the robot's creators are targeting. Digit, the bipedal robot the company announced back in 2020, had its most high-profile moment in the spotlight, after Agility announced a partnership with auto giant Ford back at CES. The auto giant currently owns 2 of the robots, with long-term plans to utilize the technology for delivery. Today's video is an attempt to showcase some more short-term solutions, putting Digit to work on more menial tasks. The value and goal of a machine like Digit is the generality. Creating human-like AI is about more than mimicking human behavior. Technology must also be able to process information, or think, like humans too if it is to be fully relied upon. New research, published in the journal Patterns, and led by the University of Glasgow School of Psychology and Neuroscience, uses 3D modeling to analyze the way deep neural networks, part of the broader family of machine learning, process information, to visualize how their information processing matches that of humans. It is hoped this new work will pave the way for the creation of more dependable AI technology that will process information like humans and make errors that we can understand. One of the challenges still facing AI development is how to better understand the process of machine thinking, and whether it matches how humans process information in order to ensure accuracy. Deep neural networks are often presented as the current best model of human decision-making behavior, achieving or even exceeding human performance in some tasks. However, even deceptively simple visual discrimination tasks can reveal clear errors. Currently, deep neural network technology is used in applications such as face recognition, and while it is very successful in these areas, scientists still do not fully understand how these networks process information. In this new study, the research team addressed this problem by modeling the visual stimulus that the deep neural network was given, transforming it in multiple ways so they could demonstrate a similarity of recognition. When building AI models that behave like humans, for instance to recognize a person's face whenever they see it as a human would do, we have to make sure that the AI model uses the same info from the face as another human would do to recognize. If the AI doesn't do this, we could have the illusion that the system works just like humans do, but then find it gets things wrong in some new or untested circumstances. The researchers used a series of modifiable 3D faces and asked humans to rate the similarity of these randomly generated faces to 4 familiar identities. They then used this information to test whether the deep neural networks made the same ratings for the same reasons. Importantly, with their approach, the researchers can visualize these results as the 3D faces that drive the behavior of humans and networks. For example, a network that correctly classified 2,000 identities was driven by a heavily caricatured face, showing it identified the faces processing very different face information than humans. Researchers hope this work will pave the way for more dependable AI technology that behaves more like humans and makes fewer unpredictable errors.
Is going to be one of the major forces for reducing the role of government. The one thing that's missing, but that will soon be developed, is a reliable e-cash, a method whereby on the internet you can transfer funds from A to B without a...
It's no exaggeration to some that digital currencies could inherit the world. Bitcoin has breached its $64,900 recent high, surging past $65,000 on Wednesday, according to data from Cointelegraph Markets Pro. For most of its existence, the cryptocurrency has been described as a bubble that is fit to burst. But so far, each stomach-churning fall has been matched with an equally dizzying recovery. Although awareness of this digital asset has risen in recent years, it remains little understood. The Financial Conduct Authority revealed in June that the number of Britons who own cryptocurrencies has surged to 2.3 million. Some countries want to ban Bitcoin altogether, India and China among them, but doing this is easier said than done. The cryptocurrency's decentralized nature means that the Bitcoin network is spread around the world. There's no single person who can be pressured to shut it down, and no one computer that can take the whole thing offline. This has created a years-long headache for regulators. And all of this comes before we discuss the cryptocurrency's impact on the environment. If Bitcoin was a country, it would be the 24th biggest consumer of energy, ahead of Poland and Egypt, and about to overtake Thailand and Vietnam. To compound the problem, less than half of the energy it uses comes from renewable sources. At the same time, we're starting to see how this cryptocurrency could potentially be used in daily life. The cryptocurrency can now be used as a payment method across El Salvador, including in Starbucks, McDonald's and Pizza Hut. Inevitably, the other question is whether Bitcoin's price could rise further. The British financial institution Standard Chartered has predicted that Bitcoin could hit $100,000, £72,000, in early 2022. A Bloomberg intelligence analyst also told me that this price is now the path of least resistance in the short term. Over its 12 years in existence, a regular pattern of 4-year cycles has formed, propelling Bitcoin to record prices before a sharp decline. In 2013, Bitcoin surged from $100 to then unprecedented highs of $1,150, only to fall by 73%. Fast forward to 2017, and a similar pattern emerged. Over the course of the year, its price rallied from $800 to $20,000. Come 2018 and it shed 80% of its value, tumbling below $4,000 at one point. If this pattern repeats itself once again, Bitcoin will plummet in 2022, decimating the investments of those who attempted to jump on the bandwagon when prices were high. Twitter is awash with crypto pundits, often anonymous, who confidently declare a single Bitcoin will be worth millions of dollars in the future. Others dangerously suggest that their followers should take out loans to purchase Bitcoin. Love it or loathe it, Bitcoin isn't going anywhere. While this latest surge will be good news for some, it will be very bad news for those who jump in at an opportune moment, blinded by astronomical gains and celebrity endorsements. So guys, I am no financial advisor, and do not believe anyone should invest into any assets unless you have taken extensive research and have the spare funds to invest. Don't listen to anyone telling you to take out a loan for a cryptocurrency you know nothing about, because more often than not you will lose a good chunk of your investment. Stay safe out there, guys. Thanks for watching. Please feel free to leave a comment with feedback and hit subscribe. What is the metaverse? Apparently, it's the next big thing. This is a concept which is being talked up by some as the future of the internet. But what exactly is it? To the outsider, it may look like a souped-up version of virtual reality, VR. In fact, the belief is that it could be to VR what the modern smartphone is to the first clunky mobile phones of the 1980s. Instead of being on a computer, in the metaverse you might use a headset to enter a virtual world. Unlike current VR, which is mostly used for gaming, this virtual world could be used for practically anything. Work, play, concerts, cinema trips, or just hanging out. Most people envision that you would have a 3D avatar. Hype about digital worlds and augmented reality pops up every few years, but usually dies away. However, there is a huge amount of excitement about the metaverse among wealthy investors and big tech firms, and no one wants to be left behind. There's also a feeling that for the first time, the technology is nearly there, with advancements in VR gaming and connectivity coming close to what might be needed. Facebook has made building the metaverse one of its big priorities. It's invested heavily in virtual reality through its Oculus headsets, making them cheaper than rivals, perhaps even at a loss, according to some analysts. It's also building VR apps for social hangouts and for the workplace. Despite its history of buying up rivals, Facebook claims the metaverse won't be built overnight by a single company and has promised to collaborate. It has recently invested $50 million, £36.3 million, in funding non-profit groups to help build the metaverse. Online multiplayer games have had shared interactive worlds going back decades. They are not the metaverse, but have some ideas in common. In recent years, Fortnite expanded its product, hosting concerts, brand events, and more inside its own digital world. That impressed many with what was possible. Meanwhile, Unity, a 3D development platform, is investing in digital twins, digital copies of the real world, and the graphics company NVIDIA. Facebook, for example, has been experimenting with a VR meetings app called Workplace, and a social space called Horizons, both of which use their virtual avatar systems. Another VR app, VR Chat, is entirely focused around hanging out online. VR has come a long way in recent years, with high-end headsets which can trick the human eye into seeing in 3D as the player moves around a virtual world. It has become more mainstream. The explosion of interest in NFTs, which may provide a way to reliably track ownership of digital goods, could point to how a virtual economy would work. And more advanced digital worlds will need better, more consistent, and more mobile connectivity. For now, though, everything is in the early stages. The evolution of the metaverse, if it happens at all, will be fought among tech giants for the next decade, or maybe even longer.